Okay, we need to cover two simple functions in MATLAB to finish discussion of Chapter 3, root finding in nonlinear equations. Those functions are called Fzero and Roots, and they do pretty much exactly what you would expect. Fzero is actually a duplication of some of the root finding methods you've just learned. So let's go over onto MATLAB and I'll actually show you a nice way to find help about any particular function. If you know the function name in MATLAB already with proper syntax, type help, then the function name, and that will display all of the information that MATLAB has contained about that function. Each function that's inherent to MATLAB has one of these built-in help data dumps, so it's very useful. The other thing you can do is, of course, just go to the online MathWorks help resource. You can search through here, and if we wanted to go to the roots documentation instead of the Fzero documentation, well, there it is. So it shows you the different types of inputs you could have into the function, some examples of those functions being used, as well as similar functions that might also play a role. There's the other one we're going to show you right now. So going back into the software, let me clear up the screen just because that bugs me. Let's look at Fzero first. For that, we need to first define a function. Feval equals handle, independent variable x. Let's just make something kind of random. X cubed minus 2 times x minus 10. Let's make it plus 2 times x. Why not? So now that is an anonymous function, very simple operation. And we can go to Fzero, type in the function handle. That could be any name. I'm just following the name of the anonymous function we just defined. And I believe I have to give it an initialization point. And it finds the zero crossing, 1.847419. So we should be able to say F0, plug in the answer, and the output is, Feval, not Fzero. Feval is our anonymous function. I made a mistake and just typed in F0. They're kind of close. Typing the answer, the output is 0, meaning we did successfully find the root of that function. If there are multiple roots, which I have not actually plotted this particular function, you could find the other roots by trying a different initialization point. So looks like we're just getting one root in this one. So that's probably the only crossing it has, being a cubic equation. So that is a very simple operation of Fzero. The other function is called roots and is more useful for polynomial, like the classic polynomial forms. So let's say we just had an equation first. I'm not even going to put this into an anonymous function. I'm just typing it out for the sake of display. X cubed plus 4.5x squared plus 3.2x minus 5. I mean, that's just an example. Did I mean that? Sure. I mean, whatever. I just want to type it on the screen so you can see what I was talking about. If you say roots and type in square brackets, so it actually needs to be an array with each column, just one row, with each column being the coefficient leading that order of the polynomial. So here in this example you have x cubed. That's actually 1x cubed. The x squared term is 4.5 times x squared. The x term is 3.2, and then the 0th order term is -5. So if we close that off and tell it to find the roots, it's done. This polynomial, as you would expect being a cubic, has 3 roots. Obviously, one is a paired root with an imaginary component, and the other is 0.719105. You can read the rest. That's a real component only. So this is very, very handy in finding the roots of polynomials of any order. If we really wanted to continue adding depth, we could. That would now be a 5th order polynomial, right? So 5th order, 4th, 3rd, 2nd, 1st order, 0th order, and that didn't take very long at all. So, very handy tool to know about, especially as you're going through finding roots of dynamic systems in some of your other classes. This is equal to or higher functioning than the root finding functions in Texas Instruments calculators that are pretty common in courses. So those are the two functions we needed to show you, roots and Fzero. Fzero is the numerical search for a zero crossing of the function, typically an anonymous function that you feed it. And roots is specifically designed only to work with polynomials when seeded with the leading coefficients. There you go.